extraction, it is about treating each colony individually. If we look at industrial scale, then we need some tools, and we are doing that in a remote way. If we look at precision agriculture generally, then there are quite many precision subfields, like precision crop farming, orcharding, gardening, horticulture. The same we have also for precision livestock farming. We can apply precision technologies for cows, for pigs, and now we are doing that also for precision apiculture. It means for beekeeping. We have given a definition of precision apiculture. That is apiary management strategy based on the monitoring of individual bee colonies to minimize resource consumption and maximize the productivity of bees. It is important that we want to do it in this project, we want to do it remotely. So we are making measurements of individual bee colonies, and afterwards we are analyzing data, and then we are developing also decision support system, which can tell us about possible states of bee colonies. So we can monitor all bee colonies continuously all the time to be able to decide where we need to make some activities, visit colonies, add honeycombs, something like that. Shortly about the project itself.
Excuse me. Biraz lütfen sessiz olabilir misiniz? Zaten biraz çevrenin sesi geliyor. Bir yandan arkadaşı izlemekte zorlanıyoruz. Sessiz olun lütfen.
So the title is Application of Information Technologies in Precision Apiculture. Apiculture is the topic. So the project was started last year, August, and will end in the 1st August of 2016. The total budget is 760,000 euro, and that's the homepage, so bitopic.eu. So about the theoretical framework of the project, we are having 4 countries participating in the project. Latvia is the most Nordic country. Germany and Denmark, they are more in the middle, and the 4th country is Turkey, which is a very, say, warm country, looking at the map of participants of the project. And we are dividing all the year in active summer period, which you all know very well. And we are doing also precision treatment in wintering period. And these are wintering buildings. So this is experimental wintering building. Inside we are having 20 colonies. And we are measuring temperature in each colony above the broad nest. And 10 colonies we are having as control outside. We are measuring both temperature and weight. So we are looking how in a particular temperature the honey consumption is going on. When do they start brood rearing in the winter? And we are comparing it with the big colonies outside. We didn't summarize the results so far, but you will see some graphs, some curves, what we can recognize. What is the goal of the project? We want to detect different colony states remotely. That means I could be sitting in this conference having my computer, and I could watch temperatures in Latvia, Germany, and I could say that a colony 2,000 kilometers from here is in danger. I could say to my colleague, please visit particular apiary and do this or something else with colonies. So we want to discover death of the colony. That's quite easy, not a big problem. We would like to see also swarming. If we can predict swarming, that would be great. Brood rearing, for instance, if a queen is lost, it would be nice to learn that we have to do something about a particular colony without visiting it. So we would visit the colony only when we see that the temperature above the nest is too low to have brood inside. So that could be quite easily detectable. And we hope to get also some other states. What do we measure? We measure temperature, humidity, sound, weight, and activity at the hive entrance. And we are having 3 systems for that. So we are going to develop such a system. And we are having, as I said, 4 partners. So this is a Turkish partner. Leader is Professor Saban Tekin, and they are concentrating on wireless applications of different sensors and sensor readings. They mostly work with temperature, and they will try to integrate also different measurements from other parts as well. We are having a video observation system from Denmark, from Aarhus University, with Peter Arendt as leader. And this is the video observation system where we are counting the bees going in, going out. We can see how many dead bees are there, so that is also a kind of measurement of activity. If we compare it to the temperature, this is very expensive measurement comparatively. Then we are working on sound analysis. Then we have Uwe Richter from University of Kassel in Germany. He has done this work with many other insects, and now he takes the challenge to work with bees. And yeah, he's doing that in a very professional way, testing the surrounding, looking at frequencies. So we hope to put all that together. And in Latvia, University of Apiculture, we have leader Alexei Zacepins. He's working on temperature monitoring of colonies and also on bee wintering. We have developed several systems to transfer a high amount of data from different locations over the internet to the central computer. And we will achieve the data visibility from most different places. So there are different architectures. We are testing it currently as the project is even in the middle. This is how we can see different apiaries. These are sensors. Here we have some curves. So these are from Latvia, and here we can see that the black curve is temperature in the bee wintering building. And the other lines are the temperatures above the nest. And we can see that we can easily detect the death of colonies. For instance, the green curve meets the ambient temperature curve somewhere in December. Another colony is dying, the red one is dying here, blue one is dying here, so we can make easy detection of death over the winter remotely. We can detect also brood rearing. So here we have January, February, and the brood is, when the temperature is going up, that means intensive brood rearing is started, and when it's about 30, that is intensive brood rearing. And at the end of this presentation, I want to tell a bit more about the concept in a regional scale. So if we are looking at an apiary where the foraging radius is about 3 kilometers, so and inside the apiary we have, let's say, 10 colonies, then in case that all the colonies have the same problem, it would be interesting if that is the case also in other apiaries. and if there are different owners of apiaries, this information would be very valuable. And for instance, in regional level, if we see that honey harvest is coming 100 kilometers from your location, that means in a couple of days or in a week it could happen in your location, be prepared. If there is illness spreading over, that means most different apiaries would be attacked. But if that is a problem of particular beekeeper, then we would see problem just in his piece. So we can apply it in regional level. So we will develop decision support systems to detect automatically what we have seen here, the mentioned states, and also regional decision support systems. Thank you. And this is the theme of our project. Thank you.